Good afternoon, dear colleagues.
Okay.
My name is Carsten Rühlemann, and I'm head of the Marine Geology section at BGR, which is a German geological survey based in Hanover. With my presentation, I would like to give you a brief overview on the potential of polymetallic nodules from Pacific's Clarion-Clipperton Zone as a metal source for the future production of batteries in Europe. This map shows the occurrences of manganese nodules in the world ocean as green areas. The dark blue stripes along the continents and islands are the exclusive economic zones of the different countries, and in light blue I show the area, that is the ocean outside the limits of national jurisdiction. The exploration areas of the European countries are located within the CCZ, which stretches between Hawaii and Mexico and has a total size of about 5 million square kilometers. This slide is a close-up of the Clarion-Clipperton Zone. The colored areas in the middle show the 6 exploration areas of contractors from Europe. They are from Belgium, Germany, France, and the United Kingdom. The contractor Interocean Metal is a consortium of Eastern European countries whose central office is located in Poland. Areas of other contractors are shown in yellow. In total, there are 17 contract areas in the Clarion-Clipperton Zone, each covering 75,000 square kilometers of seafloor. Areas shown in gray are called reserved areas, which are pre-explored and can be allocated to developing countries upon application. The green squares are protected areas where no exploration or mining may be carried out. The Clarion-Clipperton Zone is known for its dense coverage with manganese nodules and their high contents of manganese, nickel, copper, and cobalt. All these 4 metals are important raw materials that are urgently needed for the transition from the hydrocarbon era to renewable energies, especially for the electromobility. This table shows the size of the 6 exploration areas of the 5 contractors. UK Seabed Resources has 2 exploration areas. The total size is 433,000 square kilometers. So far I know, only BGR has published detailed data on its manganese nodule resources. It is therefore currently uncertain how many manganese nodules are located in the other 5 areas. However, it's possible to provide an estimate based on the BGR data. The eastern part of the BGR exploration area, with a size of 60,000 square kilometers, contains about 540 million tons dry weight of manganese nodules. The uncertainty of this estimate is plus minus 140 million tons. We have not investigated the western part of the contract area in comparable detail. Therefore, I conservatively estimate another 60 million tons of nodules for this part with a size of 15,000 square kilometers. So in total, we expect at least 600 million tons of dry nodules in the entire German contract area of 75,000 square kilometers. Based on this estimate, I consider at least 500 million dry tons realistic for each of the other 3 areas of the same size, and 900 million tons of dry nodules for the 2 areas of UK Seabed Resources. Thus, conservatively estimated, we arrive at 3 billion tons of dry nodules in all 6 areas together. Well, not all manganese nodules could be mined completely, of course. On the one hand, because a larger part of a contract area should remain untouched in order to keep the environmental impact as low as possible, but also to designate preservation reference areas. On the other hand, it is simply uneconomical to mine a seabed that is covered with only a few nodules. In the BGR area, we observed that the density of manganese nodules varies greatly from seabed areas without any nodules to areas covered with up to 35 kilograms of nodules per square meter. This graph shows an example for the eastern part of the German contract area. 540 million tons of nodules are distributed over 82% of the area of 60,000 square kilometers. The remaining 18% is covered with seamounts. The economically interesting seafloor areas, however, are those where the nodules occur in higher densities. If we apply a cutoff value of 12 kilograms per square meter dry weight, 2/3 of the nodule mass occurs on only 1/3 of the exploration area. In numbers, 340 million tons of dry nodules on 20,000 square kilometers of seabed. If we transfer this estimate to all European contract areas with a total size of 433,000 square kilometers, we can expect about 2 billion tons of dry nodules on 145,000 square kilometers of seabed. This table shows how much nickel, cobalt, copper, and manganese could be extracted from these 2 billion tons of nodules and how many batteries could be produced. If we take the average metal contents of the nodules, which are shown here in the upper line, we arrive at the following tonnages. For nickel, we get 26 million tons, cobalt 4 million tons, copper 24 million tons, and manganese 540 million tons. Based on the mass of metal needed to produce one battery, we can estimate the maximum number of batteries that can be produced from each of the metals. I show these values in the bottom line. The limiting factor is copper, marked in orange. With the copper from the 2 billion tons of dry nodules from the 6 exploration areas, 280 million batteries could be produced, corresponding to an output of 17,000 gigawatt hours according to the current state of art. If all current plans for the construction of 36 gigafactories in Europe are actually implemented, batteries with a total capacity of 430 to 770 gigawatt hours per year are to be produced over the next 25 years. This corresponds to around 11,000 to 19,000 gigawatt hours. Obviously, the manganese nodules from the 6 European exploration areas could provide metals for a large part of this battery production. It should be noted, however, that the mining of 145,000 square kilometers of seafloor would take about 100 years according to the current technical plans for the nodule collectors. This would require the mining of 250 square kilometers of seabed per year in each of the 6 contract areas. According to this estimate, mining would therefore take 4 times as long as planned for the production of the batteries. Therefore, either the manganese nodules from the Clarion-Clipperton zone can only supply part of the metals, or the mining capacity would have to become considerably more efficient. For example, by using several collectors per area at the same time. In conclusion, I think that deep-sea mining, if carried out as environmentally sound as possible, opens up the opportunity for Europe to become partly independent of resource-rich countries such as China, Russia, or the Democratic Republic of Congo, whose raw materials we currently need for our industry and the well-being of the European society. So, dear colleagues, thank you very much for your attention.